Look up at the night sky. Astronomers describe a void containing billions of galaxies and trillions of planets, a volume that stretches beyond our comprehension. When we chart the statistical probability of life against that scale, the numbers are overwhelming. With trillions of potential habitats, the existence of advanced alien civilizations becomes a mathematical certainty. By all accounts, the universe should be teeming with activity, but we are met with total silence. Decades of scanning the stars have yielded no radio signals, no alien megastructures, and no biological signatures. The physicist Enrico Fermi famously looked at this contradiction and asked, "Where is everybody?" Standard theories suggest that aliens are either hiding or have already destroyed themselves. However, a much simpler, terrifying hypothesis exists. We've failed to find life in the distant universe because those distant reaches lack physical reality. They are resource-saving projections designed to fill the void. Open-world video games provide a blueprint for this efficiency. Since rendering an infinite 3D environment would crash the system, developers only build the player's immediate surroundings. Everything else is wrapped in a flat 2D background called a skybox. A universal engine would face these same computational bottlenecks. Physically calculating trillions of planets simultaneously is a waste of processing power if no one is there to interact with them. The system solves this by limiting the playable area. In this model, the engine only maintains a fully textured 3D version of Earth. The rendering boundary extends just far enough to include our Sun and the immediate solar system. These are the only physical objects currently occupying space on the local server. To maintain the illusion of depth, the engine wraps this 3D bubble in a procedurally generated flat grid of stars, a cosmic wallpaper that makes our cage look like an ocean. Naturally, a simulation needs a way to prevent us from traveling to the edge of the map to see the stitches in the fabric. Every digital system has a maximum data transfer rate. Our universe expresses this as the speed of light, a hard-coded processing cap that throttles how quickly new environments can be calculated. It is the simulation's hardware limit, preventing any observer from moving faster than the engine can render the path ahead. Because we are locked behind this processing bottleneck, the stars remain permanently out of reach. The distance acts as an invisible wall, ensuring we never get close enough to see that the background is just paint. This theory faces one major hurdle: our telescopes. The James Webb captures incredibly high-resolution images of galaxies supposedly billions of light-years away. Quantum mechanics offers the explanation through the observer effect. This rule states that matter only takes a definitive physical state when it is being directly measured or observed. When we point a telescope at a dark, empty patch of space, the engine recognizes the request for data. There are no physical galaxies waiting in that void. To preserve the illusion, the system detects the observation and rapidly generates high-resolution 2D data. It feeds these new points of light directly into the telescope sensors. These distant images are newly rendered pixels, painted onto the inner wall of our digital cage at the moment of observation. The cosmos is silent because it was built for exactly one civilization. The entire architecture only exists to provide a localized environment for us, and only when we are actively looking. For decades, we have built rockets and telescopes in the hope of exploring a vast, infinite cosmic ocean. But that drive assumes there is actually an ocean to find. Humanity is a localized science experiment, sitting quietly inside a digital terrarium. The next time you look at the stars, try to see the system. Look for the gaps in the data and the hard edge of the map. The magnificent night sky is a painted ceiling, put there for show.